We are starting. So we're on page 31. You got handed out, you should have got the quiz, a practice one. The practice one is the summary of the main questions that are asked in vectors, and then there's a vectors review. We are going to try and do a lot of math today. See if we can even finish the booklet. That might be close. There are some extras coming around too. Okay. So here we are, intersections of lines, some applications of vectors. You've done this already in grade 10 in 2 dimensions. Now we're going to also add 3 dimensions. How can you tell if 2 lines are parallel? Well, what we did in the past is we looked, if the slopes were the same, they're parallel. But now we're going to use the vector, it's right up there, page 31. The vector equations of the lines to figure it out. So we're going to have to set up, use our parametric equations. We can set up systems of equations, solve them, and when you're solving your systems of equations, if things disappear and nothing works, because when you're solving a system of equations, you're finding the intersection point. And with parallel lines, there will be no intersection point. So when you solve them and you get a statement that's false, you'll know that the lines are parallel. Now, for this one, what we've got here, when we set up our systems of equations, when we write our parametric equations, for R1, we're going to have x equals 1 plus 3t, and y equals 2 plus 2t. And for R2, we have x is equal to 2 plus 6s, and y is equal to 3 plus 4s. We want to solve for s and t, and if we solved for that and we got values, we'd find the point where they actually intersect. Now, the reason we have 2 systems of equations is because if they do intersect, the x coordinates would be the same. So you would have that 1 plus 3t is equal to 2 plus 6s. And the y coordinates, if they're the same, you would have 2 plus 2t is equal to 3 plus 4s. We've set up 2 equations with 2 unknowns. We've got a system of equation. You can use substitution or elimination to solve. What would you prefer? Elimination. Which variable do you want to eliminate? The t's or the s's? S. Can you see that if I would multiply this equation by 2 and this equation by -3, that my s's would have the same coefficient, but one would be positive and one would be negative? I'm going to get 2 plus 6t equals 4 plus 12s as the first equation, and -6 minus 6t equals -9 plus -12s. So we chose 2 and 3 because we wanted to get rid of the s's. Now, when we add the equations, 2 plus -6 is -4. Ooh, the t's disappear as well, because 6t minus 6t is plus 0 equals -5, and the s's disappeared like we wanted to. And so we get a very beautiful statement that says that -4 is equal to -5. Okay, and this is where, if you were doing this question and hadn't seen these before, you would also feel like I did something wrong. Because this is not true. But what this means Since this is not possible, there is no intersection, and the only way two lines that are in two dimensions cannot intersect is if they're parallel. It's not the 1 equals 0.999 thing. But here, if I move up for a second, if you think of the direction vector a lot like slope, can you see that the first line, direction vector, is go right 3 up 2? If you went right 3 up 2, right 3 up 2, that would be the same as going right 6 up 4. These have the exact same right 3 up 2. That's the direction. This one, right 6 up 4, you can see that they have the same direction. Just because they have the same direction, though, doesn't mean that they for sure will, well, they'll be parallel for sure, but they might also be the exact same line. That they could be the same line on top of each other, depending on if these points were on the same line to begin with. And that is a second example.